Bismillahirrahmanirrahim. In this video, I'm going to demonstrate effect of transmission line in terms of short circuit, match scenario, and in open circuit. So I'm using a transmission line demonstrator. Here I am generating about 1.1, about 1 hertz of 1.2 or around 2 hertz of signal uh, using my feedback function generator and having an amplitude of 12 volts. And this is connected to my transmission line demonstrator that looks something like this. I have a probe that is being connected. My positive is connected to my positive side, my negative is connected to my negative side, and there is a link which is connecting my source to my load. It's just nothing but a short circuit, and that is going into that transmission line demonstrator, as you can see right here, and it's going all the way at the end. So think of it like this: this is your generator, this is your transmission line, and that thing at the end is actually your load. All right. So in this transmission line demonstrator, what I'm doing, okay, well, so what is the input impedance of this? As you can see right here, it says 600 ohms. So this port, the input impedance of this generator is about 600 ohms. This transmission line is about 600 ohms, and the load that I have connected at the end, that is also, let me show you this, that is also zero point 0.6 kilo or 600 ohms of load. So I want to see the effect of it in all three scenarios, where I have my load which is matched to my input impedance, and what will happen if I have an open circuit, what will happen if I have a short circuit. So I would like to demonstrate this. So the first scenario that I want to look at is actually a match scenario. And so here's the setup. So positive is connected to positive, negative is connected to negative. I have a link which is nothing but a short circuit that is providing power to this transmission line demonstrator. At the end I have a match load right here, which is 0.6 kilo ohms. So as you can see, now you need to visualize this yourself, because as you can see, the entire thing is being absorbed by my load, which is 600 ohms, because my transmission line is 600 ohms, the demonstrator itself, and the generator itself. So you need to observe it yourself, that this is indeed the entire signal is going and being absorbed by my load, which is 0.6 k or 600 ohms. You need to visualize it yourself. All right. At the end, so everything is being absorbed by my load. So I just want to show you this. So you need to visualize this yourself. So this is a short mass scenario. Okay, now let's do this. Now I have different type of loads here. First thing, I have a short, all right, 0 ohms, a short circuit. And then I have different type of loads like 50 ohms and things like that. Any load. So we want to look at three special cases: in a match scenario, in an open circuit, in a short circuit, as you can see it in my number line. So first thing I want to look at, let's look at if I have an open circuit at the end of the transmission line, what will happen to my voltages. So this is actually showing me voltages. I am giving about 12 volts peak to peak. So each of these block, consider this as being 2. So 2, 2, 2. And if I have a short open circuit, what will happen? So in my open circuit, normally I have voltage at the end of the transmission line, which is going to be a maximum voltage, whatever is coming from my source to my transmission line. So at the end of my transmission line, if I have an open circuit, I should see a maxima. So let's look at that maxima. So all I need to do to make an open circuit, just simply take this guy off. And now you can quickly see the effect of it, and you can see the maximum, all of these lights are like continuously lighting up. Let's look at it again. If I have a match scenario like this, when I put this load, look at the output now, and as soon as I make that circuit open, I can see that these lights clearly brightening up. Look at it now. So it's mean in open circuit I have voltage which is maximum. All right. So for a load that is match, which is this is the pattern. Okay, for a match circuit, this is the pattern you should observe. That entire thing is being absorbed by my load. You need to visualize this a little bit. Now at the end, when I make this an open circuit, as you can see right here, this is the place where you need to observe. As soon as I move this, I can see the maximum voltage at the end of my transmission line. What is the next scenario that I want to look at? I want to look at a short circuit. If I have a short circuit, what is the voltage at the short circuit? Voltage at the short circuit is actually zero. So I should not see anything here when I have a short. So let's observe this. So when I input my short circuit, which is 0 ohm short, as soon as I insert this at the end of the transmission line, my voltage is at zero. All right. So these are the three scenarios that I want you to visualize when we see a transmission line. So I have a generator which is generating a signal that is being inserted into my transmission line demonstrator. And we have three extremes: match, which we actually want. We have a short circuit. Then we have an open circuit. And we have a match circuit. All right. So these are the three extreme scenarios when you're observing a transmission line, the behavior of transmission. Of course, there are different loads. For example, let's say 50 ohms. Let's see the effect of 50 ohms. 50 ohms is almost acting as a short circuit. And then I have different type of capacitive and inductive loads and things like that. So I hope you like this small tutorial, or actually a demonstration on transmission line, where I have an open circuit, match circuit, and a short circuit. So if you have any questions, leave it in a comment section, and don't forget to subscribe to my channel.